Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about metrics. This topic is based on a tech blog with the title The Importance of Using a Composite Metric to Measure Performance, written by the engineering team from Indeed. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and technical angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. One of the fundamental needs in any business is the ability to measure performance accurately. Metrics are essential tools that help businesses quantify their success in achieving their goals. Metrics track progress, identify areas for improvement, and provide quantitative insights into specific business processes. Accurate metrics are critical because they ensure data is relevant, measurable, actionable, and usually timely. For instance, as one of the largest job sites in the world, Indeed uses metrics like job application rates and employer satisfactions to optimize their platform and enhance user experience. By tracking application rates, Indeed can identify inefficiencies in the job posting process and make strategic decisions about feature enhancements and user interface improvements. Additionally, these metrics are usually integrated with A/B testing framework to measure the impact of a specific product change quantitatively. This data-driven approach ensures decisions are made on solid data, enhancing the company's efficiency and maintaining competitiveness. Beyond the top-line metrics that measures overall business performance, a data-driven company often defines metrics for each major product group. This approach fosters a data-driven culture across the company and ensures that each organization makes relevant progresses. Well, this detailed metrics view might be straightforward for product groups directly connected to company top-line metrics. It can be challenging for groups whose impact is less direct, such as infrastructure teams or back-end product teams. Progress in these product groups often have indirect but fundamental impacts on the business. So it requires nuanced thinking to identify the connections of the group's performance versus the company's top-line metric. As described in this tech blog by Indeed engineering team, the team's goal is to measure client-side performance to ensure their investment improves the overall client experience. Client-side performance refers to how well a website or application performs from the user's perspective. It's measured on the user's device, such as their browser or their app, and can include data like page load times, rendering times, and resources loading times. The problem for the team is that they want to develop an ideal metric for the purpose, but it is non-trivial because the complexity of the backend system and there are many factors that could impact the client-side performance. Now that we understand the business problem to solve, Let's delve into the technical side to explore the team's journey of selecting the right metrics. The team has a variety of metrics to start with to evaluate client-side performance, but traditionally, they focused on one metric at a time. They would choose a single performance metric as a benchmark to decide if they were improving or degrading the user experience. This approach made tracking performance simple because they only need to monitor a single data point. Both technical and non-technical stakeholders can easily understand this information and gauge how the organization was performing. One of the earliest metrics widely used by the team was JavaScript verification delay, which measured the point at which JavaScript loaded, parsed, and began to execute. This metric was helpful for measuring whether adding extra JavaScript or content before this JavaScript bundle was degrading the user experience. However, JavaScript verification delay had significant drawbacks. It failed to capture the performance impact of third-party content. It didn't measure the actual user experience, as the page wasn't necessarily usable when the JavaScript loaded, and its implementation led to inconsistent measurements across pages. Additionally, this is a unique metric for Indeed the company, and it requires constant explanation from the team to stakeholders. In recognizing the limitations of the JavaScript verification delay, the team adopted a new, broadly used metric called DOM content load end. This metric is defined at the moment when the HTML document has been completely parsed and all deferred scripts were downloaded and executed. This metric provides a more comprehensive idea of the page performance, as it has included all the critical components of the page. However, this metric also has its issues. It doesn't capture async scripts, which means it misses out on a significant portion of the page. And similar to JavaScript verification delay, the fact that much of the code has loaded doesn't necessarily mean the page was interactive. Despite being a more standard metric, it still didn't fully represent user experience. With the previous two metrics all suffer from some problems, the team's latest single metric was called largest contentful paint. This marks a significant step forward, as it was the first adoption of a Google-recommended metric designed to measure perceived performance. The largest contentful paint, or LCP in short, aims to capture the actual user experience by measuring the time it took the largest visible content element to appear on the screen. This is particularly relevant for Indeed high-traffic job search pages, where the quick visibility of the job cards and descriptions is critical. However, this metric LCP also faced challenges. It wasn't supported on iOS and other legacy browsers. That means it didn't capture data for a significant percentage of users. Additionally, while it measured one critical component that appeared, it didn't ensure the content was interactive. And it was a web-based metric, so it excluding the native applications. All of these challenges eventually led the team to think about the problems associated with using a single metric. The life cycle of a page is complex. It involves many steps from initial navigation to user interaction. The attempt to use a single metric to understand this process removes crucial context about a user perception of page load. Historically, the team's reliance on a single metric has revealed two main issues. First issue is that no single metric can capture perceived performance. Holistic performance involves multiple aspects, and a single point in a page load can't measure how quickly a user engages with content. Different ways of building a web page brings unique trade-off in terms of performance and making it impossible for one metric to represent the overall user experience. The second issue is that improving one metric often degrades another. Focusing on a single metric can lead to efforts that harm overall performance. For example, when the team was considering reducing bytes shipped or rendering less content, might improve one metric but negatively impact the overall user experience. This approach can result in misleading or detrimental performance. This realization led to an adopting of a composite metric approach. A composite metric is a single measurement derived from multiple metrics. In this team, use a lighthouse score based on 5 data points, each representing a different aspects of page load. Industry experts have agreed on these markers and they weighted them accordingly to their contribution to perceived page speed and responsiveness. So here are the 5 metrics used in this composite metric. The first metric is called largest contentful paint. It measures the time it takes for the largest visible element on the screen to load. We discussed these metrics before. The team used this single metric previously, and this metric helps to understand how quickly users see the main content. The second key metric used in here is called total blocking time. This measures the total time during which the main thread is blocked long enough to prevent input responsiveness. Total blocking time focuses on the interactivity and how responsive the page feels. The third metric is called cumulative layout shift. It measures the total amount of unexpected layout shifts that occurs during the entire lifespan of the page. Cumulative layout shift ensures the content layout remains stable during the load. Its purpose is to prevent user disruption. The fourth metric used here is called first contentful paint. It measures the time from when the page starts loading to when any part of the page's content is rendered on the screen. First contentful paint gives the sense of how quickly the initial content is visible to the user. The fifth or the last metric involved in this composite metric is called speed index. It measures how quickly the content is visible displayed during the page load. Speed index captures the visual progress of a page loading, and it gives an indication of the user's experience. Using these 5 metrics together, Indeed can get a comprehensive view of page performance. And with the power of this composite metric, It ensures every aspect of the user experience is taken into account. This approach helps the team to deliver a fast, responsive, and user-friendly website. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we discussed the importance of having metrics for the business and associated product groups. We walked through the journey of how Indeed's infrastructure team initially started with a single metric to measure client-side performance, then eventually converged into a composite metric serving as a comprehensive measure. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.